All right, so let's look at this one, 1863. But did we do this one or?
We did look at the list. Yeah, but it's the end up getting. The problem is that the moment of inertia is in pound feet squared, but that we use simple time.
Well, that's just simple conversion.
And then we did convert.
That was the only issue, no? The conversion?
At the very end.
That should have been the issue.
Does that answer your question or no?
Yeah.
I think we discussed, yeah, that the, let me just put, all right, so. All right, so here comes, but the understanding if you want. All right, so if you have the motion of, I mean, it can be vertical or no vertical, okay? But let's say like this, or it can be like this, that doesn't matter, okay? I think because I think one of the problems is like this on the one you mentioned, no? I think there's a cable then, no? Or something like that, okay? All right. But basically the important here is A, O, or we can say here, let's say CG. All right? Okay. So, and this is bar. So let's look at bar motion. So let's do the way I want you to do it is, let's say, from point O, we say is rotation only. Correct? So for example, let's say I look at this one, it would be easier to look at it. All right, so at point O, you can remove the hole if you want or not, but let's say, I don't think I never remove it, okay, but you can remove it if you want. But in one of the problems is that we were forced to take it here because what would be the force, let's say being applied here, would be the weight now of the bar. And on this problem, we have what, another one going this way? Another force, so I think in both cases you end up having another type of other force this way. Right? But in one of the points, the weight of mg wasn't given to us, if I remember properly. Okay, so in that case, you have to take the moments because if you take moments about point O equal I sub O alpha, do you need to know the weight? What will be the moment created by the weight?
Just mg sine half one to the bottom.
Yeah, but what is the distance from? I mean, the force is going through the point, so it creates zero moment, no? Yes? Okay. So in this case, you only have this choice. But let's say you got this one here, okay, or this one, doesn't matter, and you select to say bar, you say bar motion. Now, if you look from CG, CG is going to have what? Translation plus rotation. Okay, so if you do down the figure from the CG, if you use up the motion from the CG here, what could be the vectors you're gonna have? You're gonna have here, you can have M. I mean, so I'm gonna do two figures, okay? This will be here. Remember, you always need to do two figures. So if you do from point O, then you will have only this. All right? Because when you use the polar system to move it from here to here, you're moving all the actions that happen here, you move them to here, no? All the accelerations. Okay? If you keep here now the CG, you're still gonna have here MAX, MAY, but now this will be what? ICG alpha. And now over here on the left-hand side, what will you have? MG, and let's say the force F. You understand the difference between these two figures? Yes? Yeah, but I mean, it means about which point you study the motion. So if you keep it here at the CG, now what's going to happen? This is still going to create moment, but now the MAY here, MAX here, this one is also going to create a moment about point O, no? So it's always better to go this one, not for this one. I mean, it's going to be easier. Let's put it this way. It's not better. This one is going to be one extra equation, and you need to be a little bit more careful. But do you understand the difference? Okay, so that was even this. More questions? Yes.
I have 18.5.
18.58. Yeah. Oh, yeah. Let me go look for the textbook then. Do you have the textbook on the
Here's the days you have to say textbook.
okay. I probably can access it online as well, but I've never done it. So instead of wasting time, let me just go here. ES204, bed for fallen. I guess it's this one. All right. I have the book. Here you go. 18 what?
0.5.
Cool. Okay, so on the exam, remember, I told you that you can have something like this, no? Yeah? So this type of problems, I think I told you that this is a typical kind of problem that I like to give. I think I already told you that the day I glanced to them. So 5, 8. So this is the other problem you were mentioning. Correct? Okay. But you see, it's the same thing. So this one, I think they were not giving you the mass of this bar. So you had to take the moments about this one. 5, 8. Okay, what's the question over here? The bar AB is rotating with a constant clockwise angular velocity. All right, so that means the acceleration is 0. The 8 kilograms then the bar slide on the horizontal surface. At the instant shown, determine the total force, including its weight, acting on bar BC. Okay? And the total moment about its center of mass. So, wait, what is your question? Okay, but I mean, what is your question about it? What is that you see difficult about this one? Okay, so I mean, let me just do that in the A, B, okay? I don't see anything special about that problem, that's why I'm asking. So let's say out here. So what's the problem? Like a bar like this, no? And then I'm just going to do the figure, okay? Was that the figure? ABC more or less? Oops, ABC, okay. All right, and basically they give you omega AB constant. So what is the general procedure?
Diagrams of your.
Yeah, and this is the important part. This is the most difficult part. So over here, what should be your figures? So how many rigid bodies do you have? 2. So A, B. So A, B. So personally on this one, what type of motion does this bar has? I mean, the one you just discussed, what would be the fastest way to do it? Just rotation about point A, okay? Now my question here is, let's see. All right, and the other one, let me just look at something here. What is this from? 18.58, no? Okay, personally, this one, what I would do is this, but I will have to check if it works or not. But what will be the reactions that you have over here? Yeah, these ones here, no? AY, no, AX, AY, no? And then here, I will take the moment about which equation. I will do I sub A, alpha sub A, but this is still going to be 0 because alpha sub A is 0, no? So that's going to be very, very easy. But I don't know if it's better to do this or to take one force member over here between the force BC.
So
That's the thing that I'm not. I mean, let me look at something here. Yes, go ahead.
So this one, we're replacing the supported A with forces, but
You don't have to. I mean,
because it won't really affect.
it's not going to affect anything. You take the moments about that point. I want to look at something because this is one way to do it, but then you might have to add this extra equation. If you take the force directly around BC, then just by using the first equation, summation of moments, you can already solve for the force BC. So let me see what they have done. I'm sure it's possible to do this way, but I don't want to give you something that I will do it, but what I'm trying to say is that I don't want to waste the whole class doing this problem because I think you should ask me questions about relative velocity and relative acceleration. Remember, that's also part of the exam, no? All right. So this one, don't even look at the solution, it's a nightmare. So do they do the figure here? No, not even. So. What do you mean before? Is that one problem that they had before? Okay, I don't know what they have done here, so forget about it. Yeah, I mean, it's just set up the diagram. And if you want, then I give you my second thought, okay, if you want. Then now over here, what should be the forces? It should be the ones on the opposite direction, no? By bx. And then what would be the only force at C?
Just
Should be the normal reaction because it's lining, no? Okay. And also, did they provide weights on this program?
BC has mass.
And not AB.
Not AB.
Okay, so they force you to take the moments about 0.8. That's what happened. Okay, you are forced because they don't give you the mass. And this one, you're also gonna have here the mass.
Do they give us?
And BG. Yeah, that's why this one is 0. So it's, and then over here you will have what? MB. A, this CG over here, X, no? And M, B, A, Y. You do what?
The first line doesn't have mass.
If they don't give you the mass of this one, basically what they are doing is that they are forcing you to take the moments about this point. Because what are you doing when you move? Basically, when you take the moments, when you over here, now you write down the equations, okay? Kinetic equations.
So is there, do you not have for BC? Because we have the, we've translated from C or B to the centroid.
Okay, but let's talk about that in a minute, okay? So what happened when you do this? You remember when you do this, you are moving all the forces that are happening at point at the CG, you are moving them to the point A, no? So you are also moving the weight to point A, no? Yes, that's why they don't give you the weight at AB. They are forcing you to take the moments about point A. Does that answer your question? No? Okay. Then next question, since you had that one. This problem, then after you do this, write down the equations. What you're gonna have to do, you're gonna find the velocity of B from point A, where point A you will know why. That the velocity of A is 0, no? But what would you know about the velocity of C? You will only have one on the x direction, no? So what would be the two unknowns? We have two equations, no? One unknown will be VCY, and the other one will be the omega BC. I think that was your question, no? Basically.
Yeah.
Okay. Do you see more or less the process for this one? Okay. What I don't know over here is that if this is the way I would do it initially, then if there is not enough equations, you can go to kinetics, okay? But another way to solve this problem, probably a little bit faster, is that when you do a feedback diagram of the first one, you kind of do the same thing over here, but it's the same as was done on the other two problems, is that here you can still put AY, AX, because it's going to be 0 no matter what, but here instead of putting BX, BY, just put one force here as BC. Correct? And then here you just have the I sub A alpha A. Does that make sense as well? Yeah.
So I understand why we don't do mass for the first figure. For the second one, is there a reason on the motion? Is there a reason why we don't also get the moment of inertia?
Okay, I didn't understand your question. I don't want to interrupt you, but on this one, what is the motion of bar BC? Translation and rotation. So there is no single point unless you go and find that there is no single point that the motion is only rotation, no? So on that one, you're gonna need the weight no matter what, because you're gonna have to do the MAX and the Y. Was that your question?
Partially, I think so.
Okay.
Most of it. And so is that the reason why we don't consider moment of inertia on that one at all?
On the bar BC?
On barbs?
You consider the moment of inertia. On this one, on bar BC here, when you write down the equation, you're gonna have summation of forces. On the x direction, you do summation of forces AX, and then here you don't have the choice. I mean, here you will have to take the moments about the CG over here, about this point here.
Okay. So when we do that, we're also expecting to write the.
Yeah. I mean, here you are not neglecting the CG. Yes. No, it will be taken.
We also do that as well.
Yes, and remember that the moment of inertia of a bar from its CG is equal to what? Oh, sorry. Is ICG over 12 about the CG, no? And from the ends, what do you need to do? You need to use the bar axis theorem, and this should give you ml squared over 3. I hope you know that, okay? I will only give you the one about the CG. Okay, if I give you, I will only give you this one. And if you want to move it to point A, you will have to use the bar axis theorem. That's why I just mentioned that, okay? That was it. Yep. And remember, the day of the, not the day of the exam, every single time, I'm not that concerned about the results. I'm concerned about that you show me that you understand the material, no? So figures. So if you write one equation, I want to see the figure from where the equation is coming from, no? All right. Remember, procedure. Results are not that important. So what about, you asked me a question about relative velocity and relative acceleration. So you remember we had the two equations. Let's say VA would be equal to VB plus V of A with respect to B plus omega plus S of A with respect to B. I know this is the place we're gonna have the hardest time. That's why I want to make sure. We did the most difficult ones, we did them all in class. If you do the ones we did in class, you're good. If you don't do the ones we did in class, it's not that you're not good, because what you have on the exam should be easier, but. When are you gonna have a relative term?
When the distance is not constant.
Correct, when the distance between 2 points is not constant, no? Yeah? All right, so if let us look at, I think one of the problems we did is that one, you had like a color over here that was fixed, no? And you needed to look, I think here was a surface, no? Sliding or something like that. Let's say this is A, this is B. The distance between A and B is not constant, no? As this is moving. It's not like having one bar where you have A, B, correct? So there is no relative motion between A and B, no? If this one goes 1 meter to the right, this one goes 1 meter to the right, no? They will do exactly the same thing.
We also have questions that combine kinetics and relativity.
I mean, you say problems that will combine the relative motion with the problems we just did before?
Right.
No. You can have them, but no, okay.
Sort of too much fun.
The what type of problem did we do? This one has no problem with the velocity, so what type of other problems we had? Okay, so, and then the other equation we have for the accelerations is what? Acceleration of B would be equal to what? Acceleration of B plus relative acceleration of A with respect to B plus the tangential plus the normal, and then plus what? Then that one I never remember, is 2, might be minus, I don't know, is velocity of A with respect to B. No? I don't know, I think it's plus, but I think it's minus when you put the velocity first, or is it V relative? I mean, do you have that equation with you guys?
Yeah.
It's plus that way. But I will give you these two equations, all right? And the other one. So over here, this is a relative acceleration, but we have two new terms. This one and this one. What was the name of this one? Coriolis. What was Coriolis responsible for? Earth rotation? No, but it's it's related to the Earth rotation. So we can discuss why do the hurricanes go to the left? Why does the weather goes to the left on the north hemisphere? You see, when you see the systems of clouds, they kind of move counterclockwise on the north hemisphere, no? When you have the tornadoes, or here the hurricanes, they go left, no? I mean, they rotate left. All right? If you go south hemisphere, they will go right, clockwise, no? I mean, they go clockwise, not right or left, but counterclockwise and clockwise, and this is what it's responsible for. If you drop, I mean, it's a little bit higher than here, but if you drop an object, let's say from whatever, 10 meters or whatever, 30 feet, okay, or 50 feet, 100 feet, and you drop it straight, do you think it's going to fall right straight on a straight line?
It'll be very slightly.
It's going to move, if you are on the northern hemisphere, it's going to move a little bit to the left. Why is it moving to the left? Because of Coriolis. If you look at it, is rotation of the Earth, no? Let's say whatever velocity is moving will give one that is perpendicular to the other two, no? So if you look at the Earth, you let something fall, you go to the left. This was proven by this guy Coriolis in the School of Mines. You go to Paris, you know, like a little tower, okay, in the School of Mines. And the guy, that's what he did. He dropped something and started measuring, no? How much he moved. All right. Yes.
So does that mean like, for example, if there's a hurricane somehow it crossed over the equator, it would, the Coriolis acceleration would reverse and then dissipate the storm?
Maybe. I never thought about that. I mean, on the supposedly on the hemisphere, it would not be more. So probably my guess would be if it gets to the equator, it would just stay there. You know, it will start deforming. Yeah, it will lose the motion. It will lose all the
I
momentum.
don't think it's really possible for hurricane.
Hurricanes can't cross the equator because the equator is not
Okay, I didn't know that. Okay, but that's probably the reason.
random facts.
Okay. So okay, what type of ones did we solve? I think.
I know we did a plate with a little slit in the bottom.
Okay, correct. Yeah, so I think we did a problem like, I think it was a bar like this, rotating like this, and then you can have, is that what it was?
Yes,
But then what was attached to what here?
it was a bar in the center of the slit.
Wait, was that the problem? Or what am I missing?
With the bar with one anchor, but the center is small. Not anchored. You have the center of the slit and it's rotating.
Here is got something connected,
Right, a bar
going down
down.
like this. Okay, it doesn't matter if it's something like this, okay? So in this kind of problem, so when you go, so it's called A, B, and C. When you go from B to C, do you have relative terms? Yes, no? Is the distance between B and C changing?
This should be into.
So there is no relative terms between B and C, no? Yeah, no relative terms, no?
Don't go to charge, no.
Okay, I'm waiting for your approval, but I'm gonna keep going without your approval. All right, if you now go from A to B, is the distance between A and B fixed? No, so you're gonna need relative terms? Yes, okay. Now come my question here. So let's say we write down velocity of B from point A. VA plus velocity of B with respect to A plus omega AB, because it will be two different ones, plus S of B with respect to A. Okay, what would be VA? 0. What would be velocity of B with respect to B?
With magnitude times some direction.
Okay, perfect. So it would be, so that's, yeah, so velocity of A with respect to B, B with respect to A times E, let's say, E, okay, this one, doesn't matter, plus omega AB cross S of B with respect to A. So V of B with respect to A will be unknown, but what will be E?
Just down, negative.
Yes, or positive, but basically what will be? This will be rotated by which point? It will not be rotating from this point, it will be rotating from this point, no? And the term will be either going up or down, and it will be in this direction, no? Yeah? Right?
And somewhere else. it would just be-
And then how do we find this vector? Remember, what do we do? How do you find the vector perpendicular to another one?
You take it one of them.
Okay.
So that's what why you-
All right, let's finish this one conceptually. But this will be the E, no? It will be E tangent. Let's call this one E tangent. All right. So you will have to find this one. In this case, easy because it's only on the Y, no? All right. Now for the acceleration, if you need, so, and the other one will be what? So you will write this equation, then you can write VB from point C will be equal what? BC plus omega cross whatever. BC cross S of B with respect to C. This will give you another equation that you can equate one to each other. All right, what about the accelerations? I'm just going to do AB from point A. You have acceleration of A, acceleration of B with respect to A, plus alpha AB cross S of B with respect to A minus omega square S of A of B with respect to A, plus 2 times omega cross velocity of B with respect to A. So what will be the acceleration of A? 0. What will be the acceleration of B with respect to A?
Some acceleration, some direction, but that's split into 2 terms.
Yeah, but you have one that will be normal centripetal, one term that will be tangential. Because you have what? You will have the tangential term over here, no? Correct? And you will have a normal term over here in that direction. What about this one? We don't know the magnitude. Yeah, what will be this one? Actually, this one we can know everything. What do we do with that one?
You take the tangential and then
Let's try to find out a problem, okay? That we did because pause this maybe. No relative terms. So we have B with respect to C, and VC will be 0. So basically, you will have IJK factor of 0, 0, 2. And what would be the position of B with respect to C? 60, 30, and 0. Whatever the units are, okay? So this will give us VB will be equal to negative 60, no? And negative 120. Okay? This could be our equation A. Now, the next equation we're going to do is write down the velocity of B from where? Let's call this point over here, and we call it O. All right? So we're going to go from point O. So it would be what? Velocity of O plus relative velocity of B with respect to O. So it's going to be complicated, this point. Omega plate cross S of B with respect to O. So what would be VO? 0. Now, here comes the little problem. What do we know about this term over here? This should be equal to what? We don't know the magnitude, but we should know the direction. I'm going to call it T. And if I do the figure, that one should be what?
which is
Should be tangential, either up or down, no? Yes? The should be is just going there because it should be tangential to this point. Yes? Well, I mean, it's either up or down. Even if it's so, if we did the assumption wrong, then the magnitude would come negative. Okay? So it's not a big deal, the way you assume it. But you understand why it's up? Yes. Okay, which one?
The velocity V.
This one here? I mean, this is very quick, but it will be 0, 0 minus 30 times 60, and I think this one remains the sign, no? No, I think that's, but I mean, cross product, okay, review the cross product. Okay, so over here you have this, and remember, this is just going up because this is rotating about which point? About point A, no? So the motion at any point should be tangential, no? Yes? Okay. So, and now we have plus omega p, whatever, this term stays unchanged, b with respect to O. Now, how do we find E of t? What is E? Let's say I do this one here, E.
That's the.
Yeah, what will be that one here? Okay, okay. You don't need it in this case, yes, sorry. I was trying to make complicated stuff, sorry. So this should be equal to basically 0, 1. All right. It will have worked the other way, but all right, so you saw over here VB will be equal to the unknown times 0, 1 plus IJK 0, 0 omega plate that we need to find, and then position of B. So what should be this distance over here?
Well, it was just before and 30.
Okay, 40 and 30. And 0. Okay, so this is going to give us a second equation. VB will be equal to 0 minus 30 omega plate times relative velocity of B with respect to O plus 40 omega sub P. Equation B. Any questions so far? This part should be okay. Is when the acceleration get involved that. All right. Obviously, I'm not going to do calculations. Here we equate, so the procedure will be to do what? Equate A and B. And I'm going to do some cheating here. I don't want to waste time on that. Let's just look at the solution if you want. If you want, you can check very quick. So omega A, I guess, should give you. So okay, omega plate should be 2 radians per second. I mean, let's do it since the values are so easy. So we have what? Minus 60 equal to, since the values are so easy, we can do it. So minus 60 will be equal to what? Minus 30 omega plate. So omega plate will be equal to what? 2 radians per second, no? And the equation gives you what? Minus 120 equal to the relative velocity B with respect to O plus 40 omega P. So this will give you velocity of B with respect to O equal to, so this should be what? 80, yeah. Negative 200. So basically, you were right. We should have summed the E sub T down, but it doesn't matter because it gives us a negative value, no? Okay, now. All right, now we need to do the same thing with the acceleration. So what will be the acceleration of? So I'm just going to do the first one first. Right, so let me do the second one first. So acceleration of B from point O. So acceleration of B with respect to O plus alpha plate cross S of B with respect to O minus omega squared plate S of B with respect to O plus 2 times omega plate cross relative velocity of B with respect to O, no? And here is our point O. All right, so we say that the acceleration of O will be equal to what? 0. Now, what about the relative acceleration? It's going to have a normal and a tangential. Okay, so the tangential will be this one over here, no? So we could say that this one here will be equivalent to what? To some magnitude times direction, no? Now, what about this one here? Acceleration of P with respect to O normal. It should be pointing down, no? So once again, this one, we can know the direction, no? Let's say let's call this one E normal. E normal will be what? What do you want to put for E normal? What is the direction?
Oh, negative 1, 0.
You want to put negative 1, 0? Okay, negative 1, 0. Now, what would be the magnitude? Now, what is the magnitude? This should be an angular velocity, no? Going in, correct? Sorry, a normal or centripetal. What is the general expression for centripetal? Omega squared R, but we also know what? That V equals omega R, no? So we did the combination, we say acceleration here, let's say centripetal or normal, let's say normal. So centripetal, normal, will be equal to what? Here, omega should be equal to what? V over R, no? So it will give us V squared divided by R squared times R, so this should be equal to what? V squared over R. And if you remember when we kind of did this point, what did I give you over here? So if this is the direction, what will be the magnitude of this one? V squared over R. But which V? This is with respect to what is moving over here. What is the velocity of this moving over here? But it's the relative velocity, no? The one we just calculated. All right. I don't know if I lost you, like, but anyway, so basically this equation we have how many terms at the end? You have 1, 2, 3, 4, 5, no? So now it's just a matter to go and substitute. It will be A of B will be equal to what? This will be, the magnitude will be unknown, but the direction is known, no? Yes, sorry, 0, 1. 0, 1 for this one. Now, for the second one, actually everything will be known. So we know the previous magnitude, so which is what? Minus 200. All right, for this one. Maybe let me change the divided by R, and what would be R? The distance between this one would be the 40, if you want here the 40, okay? And this will be what? Equal to negative 1, 0. We know the direction. Then here you can do the I, J, K, which will be equal to what? 0, 0 alpha plate that you need to find. And what what is the position of B with respect to O? 40, 30, and 0. Then you have the next term, which is minus omega of the plate that we just calculated, 2 squared, times 40, 30. And the last one plus, I like to do it this way, 2ijk. What do you find for the relative velocity? So we have what? 0, 0, negative 400 because I multiply by 2. Oh no, sorry, I did the mistake. It's omega. So 0, 0, what was omega p? 2. So then I think we have something wrong here. Are you sure it's not? I think the here is v with respect to O times omega p. Can you check your notes?
We did it with respect to M.
No, but is the equation omega cross v or is v cross omega?
It's
So
omega.
it's supposed to be-
Positive.
Yeah. it's omega.
Okay. So this should be then 0, 0, 2. And then this time here should be what? Should be 0. So this one will be negative 200. And this one then I put 4 over here, no? It's 2 times 2. Because it's this 2 over here, so you need to multiply one of these terms by 2. So 0, 4, 2. And basically, out of this equation, how many unknowns do you have? This one over here? No, you only have 2. You know VB, no? We just calculated. So this should be, if you want, equation C. And then if we do the other equation, which is the acceleration of B with respect to C. Yeah? B with respect to C. Again, I'm going a bit fast because acceleration of B with respect to C. Do we have a relative term? Oops, plus S of B with respect to C minus omega squared BC S of B with respect to C. So remember, this is this bar over here, no? So what is the acceleration of C? 0. This is alpha. Started to go too fast, okay?
That has to be C.
Now this will be equal to, oh, alpha was constant, no? So this is 0 as well. So correct. So we have AB will be equal to minus, how was omega B?
6.
No, it was given to us.
Omega B is 2.
Is it 2?
2. Yeah, so 2.
2? Guys, is it 2?
Yes.
So 2 squared, and position of B with respect to C was
Negative 6.
I should have it here. Negative 60 and 30, no? So basically, this will give you AB will be equal to what? 4 times 60, so it should be 40. And then this one will be minus 120. So A, B, C, D. Now what do you do? Correct, equate C and D. So which will give you what? You have 2 equations. You have 2, so this one has 0 unknowns. From the previous equation, we have 2 unknowns that were the relative acceleration and the acceleration of the plate, no? The angular acceleration of the plate. So you can just go and solve. I mean, we did a lot of these problems. I don't think we're good at it, but you need to practice, no? Solve, whatever that is, no? I don't care.
There was some that
Yeah, it was even something more interesting than that. The problem we solved in class, I think we have one, correct me over here. I think was the one you just showed me on the class notes was like, I don't know, something like this. There's one point that is something like this. Correct? So this one has everything. That one is good. All right, so for this one, I don't remember. I mean, you have the class notes. What are the points called? That way is the same as the solution we did in class. A is this one here?
B is the right side. And C is the center.
Correct. Okay, so this one. Again, if you have to solve this one, I'm just going to talk about it, okay? But if I work on this one. So, like always, is a strategy to always find the velocity or the acceleration of one point from two different locations, okay? So over here, obviously, is always the point of contact. So we can find the velocity of A from which two locations?
B and C.
From point B, and let's say point P. So do we have a relative term between B and A? No. Are we going to have a relative term between A and P?
Yep.
Yes. Okay. So now, so for example, you write out here velocity of A. I'm just going to write down this one. From point P will be velocity of P plus relative velocity of A with respect to P plus omega whatever C cross S of A with respect to P. All right. What is the velocity of P? 0 because it's rolling. Now, what would be the relative velocity of A with respect to P look like? I mean, I don't think it's going up and down, but it would be what if you need to plot it? This is rotating about which point? Point C. So either up or down. I'm going to do it up because I have more space. But basically, should be perpendicular to this one. Yeah? Okay, good. So basically, this is this one, but let's call this one also E tangent. So the whole reason why I'm doing this is how do you find the E tangent? We did that in class as well. Multiple times. Yeah. So if you remember, what would be E? What would be the one that goes from here to there? What is E? So if you remember, we did a couple of things, is that we say a vector is equal to what? So it's a vector, let me call it U bar. We even talk about the movie Despicable Me. What is the qualities of the vector? It has what? Both magnitude and direction. You see? Useful to watch movies, no? Mm-hmm. So, if you want to find the directions, what do you need to do then? You're going to divide the vector by the magnitude, no? Yeah? Okay. What is the vector AC? Do we know this vector AC? So what would be, let's say, what is UAC? What is this vector? I mean, do you have the problem? What is this problem?
This is 17.139.
139?
Great.
This one here? Okay, so basically it gives us the angle. So maybe it has to do with the angles then. What the radius is what?
At 1 foot.
1 foot? Okay. And they give you this angle is 45, no? Okay, so what would be then this vector? 1 cosine 45, 1 sin 45. correct? And this will be U, this will be the magnitude, and this will be the direction, no? Yep, okay. So then that means that E will be equal to what? I mean, this case is going to be the same, but because the radius is 1, but should be equal to what? Cosine 45 sine 45 divided by divided by 1, no? In this case, it's so silly, but it's because the radius is 1. If it was 2, it would be different, no?
Right. Yeah.
Have to take the minus. So basically, we can say that A, what I'm trying to do, oh, sorry, guys. So basically, we can say that A is equal to cosine 45 sine 45. Now, to find E sub t, what do you need to do with this one? So you flip the order, so you flip sine 45 cosine 45, and then what do you need to do? Switch one of the signs, but Neil, just think about it, okay? This is perpendicular, so you switch the signs, so you switch the order, and then if we plotted this one, let's see, is the y component positive or negative for this vector? Positive, so we can keep this one positive. Is the s component positive or negative? Negative, so we need to switch the sign for this one, no? We have done that, no? Okay. So we have this. So now when you go now to this equation, what can you say about this term over here? You're not gonna know the magnitude, but you're gonna know the direction, no? Okay, so this problem again, so you do this with the velocities, and then if you need to do the same thing for the accelerations, you're gonna have the same thing. You're gonna have one acceleration that's gonna be over here tangential, no? Where you're not gonna know the magnitude, but you will know the direction. Then what about this one? And you're also gonna have here one relative acceleration of normal. And what will you know about the normal? P with A with respect to P. Sorry for that. You will know the relative velocity, no? Square, the same thing we did before, divided by R. And then you have to use here, be careful here, you can either put the sign, no? But if you make this one going up, as you did at the beginning, then you need to put the sign over here, no?